Are you ready to dive into the mind-bending world of quantum entanglement? Prepare to have your understanding of reality shaken to its core. Quantum entanglement is a fascinating phenomenon that defies our intuitive notions of how the universe works. It's a concept that challenges our conventional beliefs about the nature of particles and their behavior. Imagine two particles, let's call them Alice and Bob, that become entangled. Even if they are separated by vast distances, their properties remain linked in a way that seems to defy the laws of physics as we know them. When we measure a property of Alice, we instantly know the corresponding property of Bob, regardless of how far apart they are. This spooky action at a distance, as Einstein famously called it, has baffled scientists for decades. But quantum entanglement is not just a theoretical curiosity. It has profound implications for our understanding of the fundamental fabric of reality. It suggests that particles are not independent entities but are intrinsically connected in ways we are only beginning to comprehend. This realization has sparked a revolution in various fields, from quantum computing and cryptography to our understanding of the nature of consciousness. In this video, we will embark on an exciting journey through the quantum realm, exploring the mind-boggling implications of entanglement and how it is reshaping our worldview. We will delve into the fascinating experiments that have demonstrated the reality of this phenomenon and the cutting-edge research that is pushing the boundaries of our knowledge. Brace yourselves, as we unravel the mysteries of quantum entanglement and uncover its potential to revolutionize our understanding of reality itself. Get ready to have your minds blown. The foundations of quantum entanglement. Quantum entanglement is a fundamental principle of quantum mechanics. It describes a situation where the properties of two or more particles are inextricably linked, even when they are separated by vast distances. This means that measuring the state of one particle instantly affects the state of the other particles, regardless of how far apart they are. The concept of entanglement was first proposed by Erwin Schrödinger in 1935. He used the famous thought experiment of Schrödinger's cat to illustrate the strange implications of quantum mechanics. In this thought experiment, a cat is placed in a box with a radioactive source and a poison. The fate of the cat depends on the state of a subatomic particle. According to the principles of quantum mechanics, the particle exists in a superposition of states until it is observed. This means that the cat is simultaneously alive and dead until the box is opened and the state of the particle is measured. Schrödinger's thought experiment highlighted the counterintuitive nature of quantum mechanics and the concept of entanglement. It showed that particles could exist in a superposition of states and that their properties could be linked, even when they were separated by great distances. Experimental evidence of quantum entanglement. While the concept of quantum entanglement seemed bizarre and counterintuitive, it has been experimentally verified numerous times. One of the most famous experiments that demonstrated the reality of entanglement was the Aspect experiment, conducted in 1982 by Alain Aspect and his team. In this experiment, pairs of entangled photons were sent in opposite directions. The polarization of each photon was then measured by detectors placed at different angles. According to the principles of quantum mechanics, the measurement of one photon should instantly affect the state of the other photon, regardless of the distance between them. The results of the Aspect experiment confirmed the predictions of quantum mechanics and provided strong evidence for the existence of quantum entanglement. The experiment showed that the properties of the entangled photons were indeed linked, even when they were separated by great distances. Since then, numerous other experiments have been conducted to study and verify the phenomenon of quantum entanglement. These experiments have not only solidified our understanding of entanglement but have also opened up new avenues for its practical applications. Applications of quantum entanglement. Quantum entanglement is not just a fascinating theoretical concept. It has practical applications in various fields. Here are some of the most promising areas where quantum entanglement is making a significant impact. Quantum computing. Quantum computers harness the principles of quantum mechanics, including entanglement, to perform calculations that are impossible for classical computers. Entanglement allows quantum computers to process vast amounts of information in parallel, leading to exponential speedups in certain calculations. Quantum computers have the potential to revolutionize fields such as cryptography, modeling and simulation, optimization problems, and machine learning. By leveraging the power of entanglement, quantum computers could solve problems that are intractable for classical computers, opening up new frontiers in computational power. Quantum communication and cryptography. Quantum entanglement also has applications in secure communication and cryptography. Entangled particles can be used to transmit information in a way that is fundamentally secure from eavesdropping. Any attempt to intercept or measure the entangled particles would disturb their state, alerting the legitimate parties to the presence of an eavesdropper. This property of quantum entanglement has led to the development of quantum key distribution (QKD) protocols, which allow for the secure exchange of encryption keys over long distances. QKD systems are already being deployed in various industries and organizations for secure communication. Quantum sensing and metrology entanglement can also be used to enhance the precision and sensitivity of measurements in fields such as sensing and metrology. Entangled particles can be used as highly sensitive probes for detecting subtle changes in magnetic fields, gravitational fields, or other physical quantities. Quantum sensors based on entanglement have applications in fields such as imaging, navigation, and precision timekeeping. They could lead to significant improvements in areas like medical imaging, mineral exploration, and geodesy. Exploring the foundations of physics beyond its practical applications, quantum entanglement has profound implications for our understanding of the fundamental nature of reality. The strange and counterintuitive behavior of entangled particles challenges our classical notions of causality, locality, and the nature of information. Researchers are exploring the connections between entanglement and other puzzling aspects of quantum mechanics, such as the measurement problem and the role of consciousness in the collapse of the wave function. Entanglement is also being studied in the context of quantum gravity and the search for a unified theory that reconciles quantum mechanics with general relativity. These investigations could lead to a deeper understanding of the fundamental laws that govern our universe and potentially provide insights into the nature of reality itself. Challenges and future directions. While quantum entanglement has already revolutionized our understanding of reality and opened up new avenues for technological applications, there are still many challenges and unanswered questions in this field. One of the main challenges is maintaining and controlling entanglement over long distances and in complex systems. Entanglement is fragile and can be easily disrupted by environmental factors such as temperature, noise, and interactions with other particles. Researchers are working on developing more robust and scalable entanglement systems to overcome these challenges. Another area of active research is exploring the connections between entanglement and other mysterious aspects of quantum mechanics, such as the measurement problem and the role of consciousness in the collapse of the wave function. Some researchers are investigating the possibility that entanglement could provide insights into the nature of consciousness and the relationship between the observer and the observed. Furthermore, the implications of quantum entanglement for our understanding of reality and the fundamental nature of the universe are still being explored. Researchers are investigating the connections between entanglement and concepts such as non-locality, causality, and the nature of information. As we continue to push the boundaries of our knowledge in this field, we may uncover even more profound insights and revolutionary applications that could reshape our understanding of the world around us. Quantum entanglement is a truly remarkable phenomenon that has challenged our conventional understanding of reality. From its humble beginnings as a thought experiment to its present-day applications in fields such as quantum computing, cryptography, and sensing, entanglement has proven to be a powerful and transformative concept. The experimental verification of entanglement has not only solidified our understanding of quantum mechanics but has also opened up new avenues for technological advancement. Quantum computers, secure communication systems, and highly sensitive sensors are just a few examples of the potential applications enabled by entanglement. However, the implications of quantum entanglement go far beyond its practical applications. It has forced us to rethink our fundamental notions of causality, locality, and the nature of information. The strange behavior of entangled particles challenges our classical worldview and suggests that reality may be much more interconnected and mysterious than we ever imagined. As we continue to explore the depths of quantum entanglement, we may uncover even more profound insights into the fundamental nature of our universe. Perhaps entanglement will provide clues to resolving the mysteries of quantum mechanics, such as the measurement problem and the role of consciousness in the collapse of the wave function. Or maybe it will lead us to a deeper understanding of the relationship between quantum mechanics and general relativity, paving the way for a unified theory of everything. One thing is certain: Quantum entanglement has already reshaped our understanding of reality in profound ways, and it promises to continue revolutionizing our worldview as we delve deeper into its mysteries. As we embark on this exciting journey of exploration, we can only imagine the wonders and paradigm shifts that await us in the realm of quantum entanglement.